Okay, so I'll keep this short too. The previous one did a really good job. So here I am just to give you an update of what IETF ARMD have done, the progress. So a little bit background. In last NANOC in Denver, we ran a track, ARMD track, have some people from operator side to give their view on the issues they see, the modern data center address resolution scaling issues. And the goal of this talk is really during our communication with various data center operators, some of them have expressed that they don't really want to disclose their issues and problems publicly. And so we just put together some generic data center designs and pain points. So hopefully we put it together here and mainly for you operators to challenge those issues and challenge those designs and tell us some of the designs are not correct or give us some more input on what other problems you may have seen. Okay, so the first scenario, the typical data center design, I'm sure lots of you probably are familiar with this, is basically layer 3 all the way to top of rack switch. And each top of rack switch is this on L3 domain. So all the address resolution are done by the top of rack switch. And because of the limited number of hosts can be put into one rack, there's really no ARP or ND issue or scaling issue at all. And this is, if operators done network this way, everything's good and happy. However, as the data center started moving into more rapid application, multi-tenants or different type of applications, some operators need to change the application on particular physical servers from one application to a different application. So with this kind of design, basically, if you want to change the load on particular server to a different application on a different subnet, you have some little trouble. Either you have to reconfigure the switches with different IP addresses, or you are constrained to put your application on particular fixed rack. Another issue people run into is when the virtualization starts and when you want to move some virtual machine from one rack to another rack, and you basically have to reconfigure the IP addresses. And if operators are okay with all those kind of reconfigurations, everything's fine. So here come to the second scenario. Second scenario is like L3 go all the way to aggregation switches. And this is also typical. We have seen quite a few data centers with this kind of design. So this kind of design has a little bit more flexibility. Basically, if you move virtual machine from one rack to another rack, you don't have to reconfigure the top of rack switches or IP subnets. And when you want to change the workload on particular physical server to different applications which are supported by your neighboring rack, you don't have to reconfigure the IP addresses. So that gives you some level of flexibility. However, under this kind of design, you still need to reconfigure switches, the IP addresses on the switches if you want to go from this group of racks to another group of racks. So some operators choose to implement a bigger L2 domain, basically having more number of racks to be under this L2 domain, so that you can move virtual machine from one rack to another rack with a bigger range of number of racks. And also that when you move, reload the servers with different applications, you have more freedom on what application you can put onto servers on which rack. So what triggers all those needs? What we have seen is with lots of newer data centers, the demand go up and down. And this is especially true for some data centers with multi-tenants. And demand go up and down, and they need to consolidate their usage into a smaller number of racks when the demand is low, so that you can shut down some of the racks, and expanding to more racks when the demand goes up. And another example is applications hosted by data center, some the demand can go up and down at different rates. So take one of the operators we work with, they do lots of online gaming, and that's what they see a lot. Like some games being popular today, needing thousands of servers supporting that game. By tomorrow, a new game comes up, and then all those servers need to shift from game A to game B. And they don't want to physically move those servers from one rack to another rack. They want to be able to reconfigure the same server with different applications, and different applications may be on a different subnet. Okay, so that's why they need this. So what are the pain points? So pain point, I just described it in different traffic flow. When there's external peers need to talk to hosts inside the data center, what the routers normally need to do is to hold those data frames, trigger the ARP and ND module to look for the target. If they cannot find the target after a number of tries, they have to drop those data frames. So this process is not only CPU intensive, but it's also buffer intensive as well. Another type of traffic is from internal hosts to external peers. So when internal hosts need to talk to external peers, the first thing you need to do is to send an ARP or ND request to the default gateway to find the gateway's MAC addresses. So this, when you have large number of hosts, whether in one subnet or when in multiple subnets, when the number of hosts increase, the number of hits to the router get large. And for IPv4, many vendors implement a solution of having gateway to send out gratuitous ARP. So that mitigates lots of, reduce the number of requests from the host to the gateway. However, for IPv6, hosts need bidirectional communication before they can send any data packet to a different subnet. Therefore, even if they receive the unsolicited neighbor discovery request from the gateway router, they still need to send a unicast ND request to the gateway router. So that still has lots of number of requests to be processed by the gateway router. So the third scenario is when you have two distinct subnets under the L2, L3 gateway. So this one has combined the problem of the first two scenario we just mentioned. So basically, from the subnet, originating subnet, they need to send ARP and ND requests. And for the destination target subnet, the gateway router has to initiate ARP or ND requests to the target. So this is not only CPU intensive, buffer intensive, so there's twice the amount of work. And this one is about overlay. And recently we have seen lots of overlay drafts coming to IETF. And overlay can be trail-based, can be Mac-in-Mac based, can be any of the three drafts listed here. It's all about overlay. The differences is where you do the overlay, right? Sometimes you do overlay on top of rack switches, sometimes you do overlay on the hypervisor. But whether you do overlay or not, the hosts in the data center need to communicate with external peers. And somewhere in the data center, there need to be a place which resolve all those addresses. So the overlay and address resolution overlay doesn't solve the address resolution issues. And you still have a bottleneck in the gateway for all the peers communication with external, or one subnet to another subnet. So here I am just presenting those kind of progress, and we want your feedback. And if any of the slides is familiar to your situation or situation you foresee in your network, we're looking forward to your time to talk to us. And we are in the process of putting the problem statement in IETF. If you can provide wording or any text, that will be greatly appreciated. And tonight we'll be at the Beers and Gear and talk to us. Thank you.
Great, we've been doing really well on time. We do have time for a question or two if somebody would like to ask one. I thought we had a question.
Hi, Benson Schlieser with Cisco and RMD co-chair. Thank you, Linda. The only thing I have to add is, as a gentleman from Facebook said, if this is your network, dot, dot, dot. Maybe it's just that easy. We're looking for that kind of feedback, and anyone who's willing to help write text for our problem statement, I'll buy you a beer. So, thank you.
Nice.